Hello. So you've come here to learn about the diesel engine, huh? Well, you've come to the right place. I can tell you all about it. Who am I, you say? For I am Rudolf Diesel, and I invented the diesel engine in 1892. When I was a young engineer living in Paris, I had an idea about modifying the gasoline engine so that it would ignite fuel by the heat of compression instead of by a spark as in the gasoline engine. Well, it was quite an idea. Here, come let me show you how it works. This is something quite familiar to you, the four-stroke cycle commonly used on gasoline engines. My diesel engine uses the same cycle, but does some things differently. For example, let's take a look at the intake strokes for both engines. On the gasoline engine, when the piston moves down, both air and fuel are drawn in through the intake valve. The amount of air and fuel allowed into the cylinder is regulated by the carburetor. But look here on the diesel. Only air is drawn into the diesel cylinder on the intake stroke, and the amount of air that goes in is not regulated because there is no carburetor. Now, in the compression stroke of the gasoline engine, as the piston moves from bottom to top dead center, it compresses the air-fuel mixture from approximately 8 parts down to 1. But in the diesel cylinder, air is compressed to approximately 20 parts to 1. This is more than double the compression of the gasoline engine and causes the air temperature in the diesel cylinder to rise over 1,000 degrees Fahrenheit. This takes us to the power stroke. The air-fuel mixture in the gasoline engine is ignited by the spark from the spark plug. The burning fuel creates the pressure that forces the piston down. In the diesel engine, fuel is injected directly into the combustion chamber, where it contacts the hot air and begins to burn immediately, forcing the piston down. This is called compression ignition. And finally, we have the exhaust stroke, in which the burn mixture is pushed out of the cylinder by the piston through the open exhaust valve. Just think, the air-fuel mixture ignited without the aid of an ignition system. Ingenious, isn't it? Of course, this design does require the use of a timed, high-pressure fuel injection system. When I built my first diesel engine, I found there was an immense release of energy from the fuel, providing a large, efficient source of usable power. This power was so efficient, in fact, that after my death in 1913, the diesel replaced steam engines like this one as the backbone of industry. And then it was adapted to mobile equipment, allowing efficient diesel power to be used in a variety of new ways. Diesel-powered races even appeared in a few of the Indianapolis 500 races, and did quite well. In addition to industry, I see that my engine is being used in many modern automobiles and light trucks. Now, I think that's great. The power and fuel economy offered by my engine make it the right engine for the modern transportation vehicle. In fact, I think I'll move forward in time and see how right they were. Well, times have changed, and so have I, mostly. I'm glad to see that my engine is so widely used today, because it presents many advantages over the gasoline engine. First of all, fuel consumption on the diesel is much lower than that of a comparable gasoline engine. That's because of the much higher air-fuel ratio, which allows for more complete burning of fuel. and the fact that diesel fuel contains more energy than gasoline. For these reasons, a diesel puts out a comparable amount of power using less fuel. Second, a diesel engine can maintain a higher sustained torque, primarily because maximum power on a diesel comes at a much lower RPM than on a gasoline engine. As you can see from the graph, the diesel's power curve is much higher than a gasoline engine's curve, even though the gasoline engine operates at a higher RPM. Third, the diesel has a high power output, which is due to the high compression ratio that squeezes out every bit of available fuel energy. Because of this, the diesel engine can be used in a wide variety of applications. Fourth, the diesel engine is very reliable. It can run continually for long periods of time with very little maintenance. Fifth, diesel fuel is not as volatile as gasoline, which makes it safer to handle. Sixth, a diesel burns fuel so completely because of the high air-fuel ratio that hydrocarbons and carbon monoxide emissions are very low, thus eliminating the need for many emission control components. I'd say that all these advantages make my diesel a pretty good choice for the cars and trucks of today. Don't you agree? Over the years, many different types of fuel have been used in the diesel engine. Kerosene, peanut oil, and unrefined crude oil, to name a few. But the most efficient fuel is diesel fuel. It is made from crude oil, as is gasoline, but has many properties and characteristics that are different from gasoline. Like gasoline, diesel fuel comes in different grades for different applications. In the commercial fuel rating chart shown here, the different grades of diesel fuel are given, as well as the fuel's minimum quality standards. Here are the 3 grades of diesel fuel for automotive use. 1D is a volatile, high-quality fuel used for engines that require frequent changes in speed and load. 2D is not as volatile as 1D, but is heavier and contains more usable energy. This is recommended fuel for most automobiles and trucks. 4D is heavier than both 1D and 2D and is not as volatile. It is designed for use in engines that operate at low RPMs and so do not have as many speed changes. Now let's consider flash point. It's the temperature fuel must reach so that a combustible mixture of fuel and air is formed above the fuel. The body or viscosity of the fuel is also important in fuel dispersion, as shown here by these 2 fuel injectors. And in lubricating the fuel injection pump and injector nozzles. Another concern is the amount of carbon residue present in the fuel. High carbon residue causes increased combustion chamber carbon deposits, more exhaust smoke, and higher soot contamination of the lubricating oil. Heavy carbon deposits in automotive diesels are not normal and are caused by use of improper fuel or mechanical problems. Accumulation of these deposits may cause problems such as sticking piston rings and valves and clogged injectors. The ash content specification tells us the amount of non-burning metallic residue contained in the fuel. This is normally a small amount found in almost all petroleum fuels. This sulfur specification is also very important, since a high sulfur content in the fuel can cause severe engine damage over a period of time. Gasoline normally does not contain sulfur because it is refined to a higher degree than diesel fuel. As my young friend will show you, use of high sulfur fuels such as furnace oil can cause excessive ring and cylinder wear, varnish on the piston skirts, sludge in the oil pan, and other similar problems. Just as gasoline is rated by octane number, so diesel fuel is rated by its cetane number. The cetane number indicates the ignition quality of the fuel. The higher the cetane number, the faster the fuel will burn. Always be sure the cetane number of the fuel is adequate for the vehicle. Aside from the fuel rating chart, there are also a few other things you should know about diesel fuel, such as its attraction to water and its susceptibility to cold weather thickening. Here, let's look again. Normal, non-contaminated diesel fuel is clear in color. Fuel that is clear except for globs of water floating in it or beneath it is said to contain free water. Fuel that is cloudy or muddy looking contains water that is totally mixed with the fuel and is said to be emulsified. Free water is easily removed by components in the fuel system. But emulsified water is difficult to remove and tends to cause the most damage, such as corrosion, fuel line freeze, microbiological growth, and fuel filter blockage. This makes it extremely important to have an approved, well-maintained water-fuel separator. To help prevent water contamination, never put questionable fuel into the tank. And remember, never add any additive to diesel fuel for any reason unless recommended by the manufacturer. When storing diesel fuel, always use a clean, approved safety can. Never use a galvanized container for storing diesel fuel. Diesel fuel may cause the galvanized coating to flake off and contaminates the fuel. Cold weather thickening is another concern. Diesel fuels contain varying amounts of paraffin, a wax substance. But below a certain temperature, the paraffin will come out of solution and begin to form wax crystals. At this temperature, the fuel will begin to look cloudy, which is referred to as cloud point. Fuel that has reached the cloud point can cause problems because it is thicker and wax crystals tend to clog fuel filters. As the temperature drops further, more and more of the paraffin will come out of solution until the fuel reaches the pour point. At this time, the fuel will no longer flow and the fuel system is immobilized. There are many things that can be done to prevent this, and we will go over them in the next section. The fuel delivery system is the heart of the diesel engine. In fact, 90% of diesel service problems are related to the fuel system. Most of these problems are simple to diagnose once you understand how the system works. There are several components common to most diesel fuel systems: the fuel tank, water fuel separator, fuel heater, fuel filter, transfer pump, injection pump, and fuel injectors. Component location may vary, but the functions are basically the same. The fuel tank is similar in design to those used on gasoline-powered vehicles. Only the correct grade diesel fuel should be put in the fuel tank, never furnace oil or diesel fuel of questionable quality. Fuel leaving the fuel tank must go through a water-fuel separator to remove any of the water that may be contained in the fuel. The water-fuel separator must be emptied at regular intervals according to the maintenance schedule. However, if excessive water is trapped between normal maintenance intervals, a warning light on the instrument panel will light, indicating that the water-fuel separator is full and must be drained. Fuel is also routed through a fuel line heater, which operates when the fuel is cold. The purpose of the fuel line heater is to prevent the formation of wax crystals in the fuel, which could plug the fuel filters. After going through the fuel line heater, the fuel must be filtered. Fuel filters used on diesel engines must be of extremely high quality to prevent any foreign substances from getting into the close tolerance fuel injection components. These filters must be changed according to specified maintenance intervals. Often, extra devices, such as these filter inlet screens, will be included to provide additional protection. Next, fuel goes through the transfer pump, which is used to draw it from the fuel tank to the injection pump. In most automotive diesels, the transfer pump is an integral part of the fuel injection pump. But some will use an additional automotive-type transfer pump to ensure adequate fuel flow to the injection pump. The fuel injection pump is an extremely precise piece of equipment, and the least likely to fail in a well-maintained fuel system. There are 4 different types of fuel injection systems, each using a different type of injection pump. The common rail system, the multiple pump system, the unit injector system, and the distributor system. Each of these systems has its strong points, but not all are used on automotive diesels. The most common injection pump used on automotive diesels is the distributor-type fuel injection pump. Operation of a distributor-type pump is similar to that of an automotive distributor. In fact, the hydraulic head even looks similar to a distributor cap. On the distributor-type pump, fuel is drawn in by the transfer pump located in the hydraulic head. The transfer pump will pressurize fuel to about 150 pounds per square inch to ensure proper fuel flow within the pump. The main functions of the injection pump are to raise the fuel pressure to approximately 2,500 pounds per square inch, deliver the fuel to the injector nozzles at precisely the right moment for proper ignition, and in most cases controls the maximum engine speed through the use of a built-in governor. Fuel timing is determined by the rotor position in the pump, just as spark timing is determined by rotor position in a distributor. Like the distributor, the fuel injection pump is precisely timed to the camshaft to provide fuel injection to each cylinder in the proper sequence. The fuel injection pump is an extremely precise piece of equipment which should never be tampered with. Fuel injection pump service should only be performed by service centers specially equipped to handle them. After leaving the injection pump, fuel is routed to the injection nozzles by way of high-pressure fuel lines. These lines are a matched set cut to exact lengths. If one of them should become kinked or develop a leak, it can only be replaced with a tube that is exactly the same length as the original and made of the same material to withstand the high fuel pressure. Fuel is admitted to the engine by the injection nozzles. The nozzles are also manufactured to extremely precise tolerances and perform a very important job. Each nozzle must break the fuel up into droplets that are easily burned, meter a precise amount of fuel, and perform properly for long periods of time without leaking or requiring maintenance. Let's take a closer look. The injector nozzle shown here works on spring pressure and fuel pressure. The spring will hold the nozzle closed until a sufficient amount of fuel pressure lifts the valve off its seat and allows fuel to pass. When the fuel pressure drops, the spring will quickly snap the valve shut, preventing any leakage of fuel into the cylinder and preventing any of the burning fuel from being forced back into the injector. Injectors use different types of tips depending on the type of combustion chamber. The number and location of holes, along with their size, will determine the spray pattern. It is important for you to know what the spray pattern should look like for the particular injector you are working on. You may be interested to know that the amount of fuel injected into the engine is only about 10% of the total that is transferred from the fuel tank to the injection pump. The other 90% is used to cool and lubricate the injection pump and fuel injectors and is returned to the fuel tank by way of the fuel return line. In addition, fuel returning to the tank is warm and thus helps to prevent wax formation during cold weather. At first glance, operation of the diesel fuel system may have looked complicated, but it's not. Another system that is extremely important is the diesel electrical system, which is much different from the electrical system used in a gasoline engine. See for yourself. Most diesels use a dual battery system. This is required because of the high demands presented in starting such a high compression engine. These high demands are due in part to the use of glow plugs and a fuel line heater for easier starting. The glow plug system is something that every technician should understand, especially the timing controls and wiring methods for the glow plugs, because these will vary on different diesel engines. The glow plug is a tube-shaped device which extends into the pre-combustion chamber. When current is applied, it heats up and warms the combustion chamber air for easier starting. At this time, there are two basic glow plug systems. The fast start system, which is the most common, heats up the combustion chamber in under 6 seconds. The slow start system heats up the combustion chamber in about a minute and a half. The fast start system uses glow plugs that are rated at 6 volts on a 12-volt system, while the slow start system uses glow plugs that are rated at 12 volts on a 12-volt system. Timing control on the fast start system is critical because the glow plugs will burn out if they are exposed to full 12 volts for longer than 15 seconds. After the engine is started, the glow plugs will continue to operate by pulsating at a lower voltage until the engine coolant reaches proper operating temperature. This is done to keep the pre-combustion chamber warm enough to ensure complete combustion until the engine reaches operating temperature. Service procedures for the glow plug system will vary due to the use of different timing controls and wiring methods. It is extremely important to follow the manufacturer's recommended diagnostic procedures whenever servicing the glow plug system. And that, basically, is the story of the diesel fuel delivery and electrical systems, and should start you on your way to performing most diesel service procedures. As you are no doubt already aware, diesel engines differ from gasoline engines, and this is reflected in the different service techniques and safety precautions. Some of these differences relate to engine construction and operation, but all are important to know in terms of performing diesel engine service efficiently and safely. Diesel engines are both strong and precise. They are larger and heavier than gasoline engines of similar displacement because of the higher compression ratios and internal pressures produced. Because of the high compression ratios needed to heat the air, valve sealing becomes critical, and a poor valve job will become quickly evident. Inside the fuel system, many clearances are as close as 60 millionths of an inch, making cleanliness one of the most important factors in diesel engine repair. You will also find that different techniques are used for cold weather starting, depending on the engine design. These techniques include wait time while the glow plugs warm the pre-combustion chamber, and advancing the fuel injection pump timing. Never use any auxiliary starting aids unless they are recommended by the manufacturer. Glow plug system service is extremely critical, and great care should be taken whenever you are working on the system. If you are careless, you may get results like glow plugs that have burned out because of excessive current being applied. This can easily be caused by improper service techniques and would result in costly repairs. Another difference between the gasoline and diesel engine is engine noise. The diesel engine will have a tendency to knock due to factors such as compression ignition, high compression, irregular combustion, and the type of fuel being used. You must become familiar with the types of noise each particular diesel engine makes in order to better service it. You will also notice that there will be a certain amount of exhaust smoke and odor present. This is completely normal and will usually be most obvious when the vehicle is accelerating or under load. Of course, excessive smoke or odor can usually be traced to a mechanical problem, such as a worn or malfunctioning injector or incorrect fuel usage. Diesel exhaust odor is affected by such factors as engine speed, engine temperature, exhaust system design, quantity of fuel injected, timing of the injection, combustion chamber design, and fuel quality. When you are faced with fuel system problems, it is important for you to understand exactly what you are working with. And that is diesel fuel, a fluid that is thicker and more viscous than gasoline. For that reason, any air leak in the system will cause the pump to draw air rather than fuel. Any time the fuel system is opened, or if the vehicle is run out of fuel, air will have to be bled from the system, and the system will have to be primed. This is especially true on vehicles that have a transfer pump located in the fuel injection pump. These vehicles will often have a means of bleeding air from the system, such as this priming pump, which is built right into the fuel filter. Most fuel system problems are quite easily found by the technician who knows the system. Let me say again, the fuel injection pump is the component least likely to malfunction. Check all other possibilities before having it serviced by a specialized service center. My last topic, safety precautions, is applicable for any diesel engine you service. Listen to these precautions closely. First, a diesel engine has an unrestricted intake of air. Even at idle, the cylinders are completely filling with air. Therefore, you must always cover the air intake with the air cleaner or other device to keep foreign objects such as dirt, tools, hair, or anything else from being drawn into the engine. If you do not take this precaution, engine damage may result. Second, never use starting aids such as ether or any other commercial starting fluid on automotive diesel engines equipped with glow plugs. Starting fluid fumes could be ignited by the glow plugs, and as you can imagine, engine damage and even personal injury could result. Third, you must be extremely careful of high-pressure fuel leaks. An experienced technician will never look for a fuel leak by feeling for it with his hand. He will use a piece of cardboard to determine the location of the leak. Diesel fuel is under extremely high pressure, which may exceed 2,500 pounds per square inch. A stream of fuel under this pressure can easily pierce your skin and cause severe injury by blood poisoning. In the event that you or someone else is hit by this high-pressure fuel, see a doctor immediately. Finally, I would warn you about the possibility of runaway engines. Since there is no air regulation on a diesel, the possibility of a stuck fuel rod or governor would allow the engine to run away until it has destroyed itself. In the event that something like this should occur, you must act quickly to prevent damage to the engine. There are only two things you can do: shut off the air or shut off the fuel. Either action will stop the engine. Usually, the ignition switch is used to cut off the fuel. Should this fail, the engine can be stopped by stuffing rags into the air inlet. Never try to cut air off by placing your hand over the air inlet, because severe injury could result. Well, that about wraps it up as far as the modern diesel is concerned. Well, now I must get back to my shop. And now I will leave you with one final bit of advice. When servicing a diesel engine, you can never be too clean or too careful. Well, Wiedersehen and good luck with my engine. I know you'll do well.